So we've just shown how when you're in a vertical circle, your speed will not be constant. It will not be uniform circular motion. So let's look at that a little more formally. What happens when we have non-uniform circular motion? Okay, so we'd be looking at a case where object is moving in a circle. So at this moment in time, it has a tangential velocity directed in that direction. We know that since it is moving in a circle, there has to be a net force on it, and that net force has to be pointing towards the center. This is the force that makes it move in a circle. But there might also be another force that is directed tangent to the circle. And if there is a force directed tangent to the circle, then your object is going to change its speed. It will accelerate tangentially. Okay, so this force, I want you to think whatever force is pulling it to the center, that's the force that makes it move in a circle. Maybe that's the tension because you're swinging a ball in a circle. Maybe that's gravity because it's a planet orbiting the sun. Maybe this is the normal force because you're on a gravitron ride. Okay, this is the force that makes it move in a circle. This force is going to act, in this case, to speed it up because this force is in the same direction as the velocity. That means that it's going to be going faster. That's what this force is doing. If the force were directed in the opposite tangential direction, then it would be acting to slow it down. Okay, so some forces that are always in the tangential direction would be anything that pushes your object in a forward direction, like the engine of a car would always be in that tangential direction. Or if you're flying a plane, the forward thrust pushing that plane forward would always be in the tangential direction. Things that are always in the opposite of that direction of your velocity would be like friction. Friction is always in the tangential direction but opposite the direction the object is traveling. And that always is acting to slow down the object. So what do we do if we have a force like this? Well, we do what we always do. We're going to find the net force in the r direction and the t direction. And maybe we need it in the z direction. But when we find the net force in the t direction, we can set that equal to mass times acceleration in the t direction. The net force in the t direction will equal the mass times the acceleration in the t direction. And this acceleration in the t direction, that's just telling me how fast my velocity in the t direction is changing. Or I can remember that my acceleration in the t direction is equal to alpha times r. And I can say my net force in the t direction will tell me how big alpha is. And alpha tells me how big my omega, my angular velocity, is changing. Okay. We're really never going to look at a net force in the z direction, so you don't have to worry about finding a net force in the z direction. And this thing has always been true. We've been doing that in a few examples. So again, this is the force that makes it move in a circle. And if we have a net force in the t direction, this is going to change our speed. And this is going to tell us how fast our speed is changing. Now that we have kind of looked at what's happening in terms of the forces, we can think whenever there's forces in those directions, they're going to cause an acceleration. So no matter what, when something is moving in a circle, we know there has to be a force pushing it inwards. That means that object is always accelerating towards the center. That's the reason that it turns, is because it's accelerating. But now we're considering for non-uniform motion that there might be a force in the tangential direction, in which case we would have an acceleration in the tangential direction. And if we accelerate in the tangential direction, if we accelerate in the same tangential direction as our tangential velocity, we're going to speed up. If we accelerate opposite our tangential velocity, we're going to slow down. So that tangential acceleration causes a change in our tangential speed. So I just want to remind you, this is always there. This is always there whenever something's moving in a circle. This is only going to happen if our speed is changing, if we're in non-uniform circular motion. Okay, and we can use our net force in that tangential direction to figure out our tangential acceleration, or we can use it to figure out our angular acceleration, because both of these are related, remember, just by a factor of r. But once we know our acceleration in the tangential direction, we can look at how our velocity in the tangential direction changes. Or you can also say, once we know how our angular acceleration is what our angular acceleration is, we can know how our angular velocity is changing. And then we can start looking at kinematic equations. So just like we did before, where we use our forces to calculate our acceleration, and then once we know the acceleration, we can use kinematics to calculate the other variables. We did that previously when we just had we're looking at forces in a straight line. Now we can do the exact same thing with forces for objects that are moving in a circle. Okay, so still acceleration is the one that connects the forces, what's happening with the forces, to what's happening with the kinematic variables. So let's just do a couple more examples, just practicing figuring out the sign. Okay, so let's look at this example. Here I want to show something that starts off slow and then it goes faster and faster. Okay, so if it starts off slow, first let's figure out the sign of the tangential velocity. Well, it's going counterclockwise, so my tangential velocity is going to be positive. And now if this is going to be going in that it's getting faster and faster and faster, so my tangential acceleration is going to have the same sign as my tangential velocity, and that's what we see here. We always have this positive radial acceleration because we are moving in a circle. Let's look at another example. Okay, so here I want to show something that's slowing down. Well, it's still moving counterclockwise, so my tangential velocity is still going to be positive, but now it's slowing down, so my tangential acceleration is going to have an opposite sign. It's going to have a negative sign. But again, we're moving in a circle, so our radial acceleration is still positive. Let's look here. Here I'm starting off slow and then speeding up. I'm starting off slow and speeding up, but because I'm going clockwise, my tangential velocity is negative. And then since I'm speeding up, my tangential acceleration also has to be negative because these have to be the same sign because I'm speeding up. We're still moving in a circle, so I still have that radial acceleration that's still positive. And then finally we'll do one more where we're slowing down. So in this case we slow down, and we're moving clockwise. So since we're moving clockwise, my tangential velocity is negative. And since I'm slowing down, I need my acceleration in that tangential direction to be in the opposite sign of my tangential velocity. So in this case, my tangential acceleration is positive. But again, we're moving in a circle, so my acceleration in the radial direction is positive.